So this is question 2. X, Y, Z are real numbers such that the sum equals to 0. Find the largest value of this expression. So basically, what we need to do is we start from the sum. Our target is to get y squared plus z squared minus x squared. In order to do that, we can take x to the other side and square both sides. So we have 2yz plus z squared equals to x squared. In order to get this expression, y squared plus z squared minus x squared will be equal to negative of 2yz. This expression suggests that none of the x, y, z can be equal to 0. So we can divide both sides by yz in this case. Y squared plus z squared minus x squared over yz is equal to negative 2. And therefore, y plus z over yz, y squared plus z squared minus x squared is equals to negative 2 of y plus z. And using the similar argument, then we can get this is actually equal to negative 2 z plus x. And this is negative 2 x plus y. Therefore, I can just say that this is negative 2 y plus z, negative 2 z plus x, and negative 2 x plus y. I can take out each of the negative 2. You have 2x, 2y, 2z. So another 2 x, y, and z. And since the sum equals to 0, this is equals to 0, so the answer is 0. Therefore, we conclude that 0 is the answer for question 2.